So we have to find the coordinates of all intersection points between a given line and a circle. So it's good to know that a circle and a line cannot have just any number of points. It's either going to be 2 points or 1 point or no points. It cannot have 3 or 4. If it doesn't take too much time, it might be a good idea to sketch a picture. It doesn't always help, but very often it's helpful. It might protect you from errors such as the sign of a slope or something like that. So we're just going to take a minute or two to sketch a graph. It's not part of the problem. The center of the circle is 11, negative 15. 11, negative 15. And the radius is 11 squared is 121 and 12 squared is 144. So it's somewhere between 11 and 12, which is interesting because in this case, this distance here is 11. So it's just going to go a little bit beyond the y-axis, but it's not going to touch the x-axis. 15 is too far for this circle to reach that. So it looks something like that. Now the line, if we bring it to the slope-intercept form, we're going to get y equals x minus 26 over 3, or 1/3 x minus 26 over 3 is 8 and 2/3. 8 and 2/3. Okay, so I'm not exactly sure where this circle hits the y-axis. So I'm not exactly sure if the y-intercept is here or here. But it doesn't matter. I think what matters is that probably there are going to be 2 intersection points, something like that, because it's close enough either way. But if we get something like negative 20 for the x coordinate of the intersection point, then something went wrong. Okay, so again, this is not mandatory, but highly recommended. Okay, so now we're going to use substitution. We're going to use the lines equation to express one of the 2 unknowns in terms of the other, and then we shove that information into the first equation to reduce the number of unknowns to 1. Well, x is much better of a choice here because if we solve for y, did you notice we have fractions, and that's not a good, if there is a way to avoid fractions, we probably should. So let's just say that x is 3y plus 26 from this equation, and this is the one that we're going to substitute into the equation, the first of the circle. 3y plus 26 is x. We have to subtract 11 to get, this is x minus 11 plus y plus 15 squared equals to 130. All right, so we have 3y plus, interesting, lots of 15 in this one. 3y plus 15 squared plus y plus 15 squared is 130. So we have 9y squared plus 3 times 15 is 45. So that's 90y plus 15 squared is 225 plus y squared plus 30y plus 225 again equals to 130. So we have 10y squared and 120y plus, now this is 225 times 2 is 450, and 450 minus 130 is 320. I find that very encouraging that all 3 of these coefficients are divisible by 10. That's kind of comforting. So the numbers are the numbers may be nicer than they appear now. We can divide the whole thing by 10 and we get y squared plus 12y plus 32 equals to 0. At this point, we can factor using all kinds of techniques. I think I see 8 and 4 adding to 12 multiplying to 32. So I'm just going to do what we call trial and error. Numbers are not bad for completing the square. You can use the formula, whatever you have to do. And so we get y equals -4 and -8. That would be the y coordinates of the two intersection points we predicted. So this would be at the level of -8, and this would be at the level of -4. To find the x coordinates, we go back to what we substituted. X is 3y plus 26. So x1 is 3 times -4 plus 26. And that's -12 plus 26. That's 14. So we found a point 14, -4. Be careful that we found y first, but it's still the y coordinate of the point. That would be this intersection point here. See, it's slightly more than 11, but not a lot. 14, -4. And then the other one, x2 is 3 times -8 plus 26. So that's -24 plus 26. That's just 2. It's not a bad picture here. So the other point is 2, -8. So we think that these are the intersection points. First point was 14, -4. The second point was 2, -8. And yes, we got them right. Excellent. Thank you for watching.